Okay, find the equation of the tangent line. Just like always, tangent lines, we need a point. No, we've got that. 1 pi. And we need a slope. And the slope is still going to be the derivative, but it's going to be an implicit derivative, and so we will be plugging in both x equal 1, y equals pi. And so here's a slightly new notation for us. I don't think I've used this notation before. Instead of saying like f prime of 1, since I have both 1 and the pi to plug in, x equal 1, y equal pi, I can't use that notation f prime. Plus, I don't have a function, so I can't use the notation f prime. So what this notation means is find the derivative, then plug in these values. And so there's my game plan. Just like always with tangent lines, find your derivative, plug in your specific values, that gives you your slope. So implicit differentiation. So I'm going to write my equation down again so we can all see it. xy squared plus cosine y equals pi squared minus e raised to the 1 minus x. And a product rule again. I've done lots of product rules because I've found through the years that students miss the product rule for some reason when we're doing implicit differentiation. They just don't recognize they have a product, and so they miss it. So a product rule here. Plane first, derivative the second, but I just differentiate a y, so I follow it by dy dx, plus plane second, derivative first. Product rule. Plane first, derivative second, plane second, derivative first. Up to the cosine. Derivative cosine y would be minus sine y, but I just differentiated a y, so I get followed by dy dx. And then here's a mistake that lots of people would do. Probably about the half class would tell me that the derivative of pi squared is 2 pi. Why not? Multiply by the exponent, decrease the exponent by 1. We do it all the time. Derivative of y squared was 2y, so it must be the derivative of pi squared is 2 pi. See it all the time? Unfortunately, it's completely and totally wrong. The derivative of pi squared is 0 because pi is a constant, and thus pi squared is a constant, and the derivative of a constant is 0. Then we have the e, where it repeats. Let's write this correctly. Repeats derivative of the exponent. Repeats derivative exponent. And so now we're going to solve for dy dx. Clean that up a little bit. 2xy dy dx plus y squared minus sine y dy dx equals e to the 1 minus x. The 0, don't need it. The 2 negatives are going to make that positive. Dy dx terms on one side. Terms without a dy dx on the other side. Factor out the dy dx. And then divide. So dy dx equals e to the 1 minus x minus y squared over 2xy minus sine y. So there's my derivative. Now let's remember what we were doing We were trying to find the slope. So the slope at 1 pi, yep, that was the point, was m equals the derivative evaluated at x equal 1, y equal pi, which would be e raised to the 1 minus 1 minus pi squared over 2 times 1 times pi squared minus sine of pi. And so what's that? That's going to be e to the 0 minus pi squared, 2 pi squared minus 0. The derivative of sine pi is 0, or the, not derivative of sine pi. Sine of pi is 0. And so we've got 1 minus pi squared over 2 pi squared is my slope. And nothing cancels there. The pi's do not cancel. And so my equation of my tangent line is doing y minus 1 equals m times x minus x1. The point still right there, 1 pi, there's my slope. So 1 minus pi equals 1 minus pi squared over 2 pi squared times x minus 1. And then however you want to write that, in my opinion, that's a perfectly good, fine, and happy answer. Leave it like that. Now this one we really can't check by looking at a graph because our basic graphing calculators can't graph the curve that we were given. And so this one we just have to hope that we did it right. Okay, so this had 3 things in it though. Verify the point, we did that. Find the equation of the tangent line. Now find the normal line. It's like, oh God, I gotta do all this work and get another one? Well, it won't be that bad. Find the equation of the normal line. This is just a matter of learning a new word. The normal line is the line perpendicular to the tangent line. Normal is just another word, means perpendicular. Mathematicians have 3 words for perpendicular: perpendicular, normal, and orthogonal. So then we just remember a little bit of algebra. Recall perpendicular lines have negative reciprocals for slopes. That says slops, not slopes. So, recall the tangent slope was m equal 1 minus pi squared over 2 pi. So the normal slope is going to be m equal negative 2 pi over 1 minus pi squared. And you can simplify that any way you want. The prettiest way to simplify it is to specifically think that, okay, we're going to put the negative sign in the denominator. And so then I have 2 pi over negative 1 minus pi squared, or that's 2 pi over pi squared minus 1. Now, I don't particularly care if you simplify it, but my gut feeling, the computer would have this for the slope. And so then the normal line would be y minus y1 equals m times x minus x1. And so y minus, and again, the point was 1 pi. The point was 1 pi. So y minus pi equals 2 pi over pi squared minus 1 times x minus 1. And there's my normal line. And that's the end of this section.